Hi, we're on statistical applications, video 5 already. This is hard to do if you haven't seen it before, so I hope I've provided enough information. We were doing example 5, and so I had built a true and false. Say I had built a 90% confidence interval for the mean diameter steel rods. Let's say this is the confidence interval. The question is, which one of these statements is true? This means that we are 90% certain that the interval contains the true population mean mu. That is correct. And no, this means there's a 90% chance that the interval contains the sample average. Well, we know that the sample average actually is in the center of this confidence interval because we build it with x bar plus or minus. So we know that we are 100% certain that x bar is in there. In fact, we know it's right in the center. So I hope that makes sense. It's more just the language that when you build an interval, you're building it for a parameter, an unknown population value, and you use your sample data to construct it. So let's go down. How to determine the confidence level. So now, right now, you know confidence interval will be x bar plus or minus so many standard deviations times whatever the standard deviation is. But this value depends on how much confidence you want. And since we're building these with, yay, another video is posting. Let me switch over though to, back to this lecture. We call this a z-score. A z-score is really just how many standard deviations you're going to go in either direction. And the notation for it is z of alpha over 2, because if you want a 95% confidence interval, that means alpha is 5%, and then you take half of alpha, because we're always going to be building two-sided confidence intervals, so you want half of this probability in each tail. So for example, so the positive will denote leaving that much in the right tail, the negative will be leaving that much in the left tail. So for example, let's say we were building well, let's just go here to the 90% confidence interval, okay? So if I want 90% area under the curve, then I want 10%, so alpha in this case is 10%, and I want to break that equally into the two tails, so this is alpha over 2 is 5%. Alpha over 2 is 5%, that's 0.05 and 0.05. So I go to the z table, and that's what I'm going to call this value, the value that leaves 5% in the left tail and 5% in the right tail. So if I go to my z table, the value that leaves 5%, we're getting closer. Looks like it's very close between these two values right here, and I don't care if you round or 1.64, 1.65, a lot of people say 1.645, so in this case I'll go back, and you see then that's why I'm giving z of alpha of 0.05. If you want to leave 0.05 in the tail, the z-score is 1.645. If I want to leave 0.01 in the tail, that must be, 01 must be a 98%, right? Because 98% confidence interval would leave 1% here and 1% there. If you go back to your table, let's see, 1% is, I'm going the wrong way. Let's go over. We're getting close, right? I was doing pretty good with 1%. About here, negative 2.32, negative 2.33 leaves 1% in each tail. Is that what I said on the, why did I say 2.58? Where's 2.58? 2.58 leaves 0.005, 0.005 in each tail. Do I have something wrong on here? Let me see. Z-score. So that was right, and 1.96, and this is wrong. This should be 2.33, right? a z-score of negative 2.33 leaves 0.01 in the tail, right? So let's go back. Make sure, right? 2.33 leaves 0.01 in the tail. So I guess I found myself an error on my lecture there. Okay, so anyway, that's how I determine how many standard deviations I'm going out. That depends on confidence then. So here's the official definition of a confidence interval. X bar, and then here's the standard deviation, and then here's that z-score we were just doing. We call this the standard error of the mean. It's sigma divided by square root of n. The reason why I'm saying when n is large, remember that x bar doesn't take on a normal shape unless we choose n large enough and we sum enough of the random variable together, but 30 is being very, very conservative. Often we don't need 30, as you probably saw in that applet we used earlier. So back to this again. Yeah, this was wrong. Remember, so if I want to leave alpha is 0.01, then 0.005 is alpha over 2, so this is the right value for 0.005. If I want to leave 5% overall, that's 0.025 in each tail, 0.05 in each tail. So these are the most popular z-scores you'll see, because you usually build 99s, 95s, 90s, but we'll practice. So down here, mean time to assemble a bike for a random sample of 40. So you ask 40 people to practice, put together a bike. You're not sure how long it's actually going to take, but you want to maybe put a confidence interval on the bike, on the box, like here's how long it's going to take you. So here was 40 people, and it took them 10.4 on average. I mean, that's the average for 40 people. And we know sigma is 1.2. Okay, so we want to make a two-sided 90% confidence interval. So this should be 10.4 plus or minus 90%. So sometimes I even draw to make sure I believe it. So here's 90% in the center, so that leaves 0.05 and 0.05 in each tail. So the z-score is 1.645 times 1.2 divided by square root of 40. And I should give you an interval, but I don't have Maple up at the moment, so you would get a lower bound and an upper bound, and then I'd say I'm 90% certain that this contains the true mean time for everyone in the world to put together this bike. That's, you know, and I think we said this is a random sample of 40, so I didn't need to assume morality of the original distribution. This could be from any distribution. We know when n is 40 that the graph of x bar here is going to look normal. So determine a two-sided 99% confidence interval. Only difference is 99% leaves 0.005 in the tail, so that's 2.58 times 1.2 divided by square root of 40. Just for extra practice, let's say we're going to build an 80% confidence interval. It's kind of weird, but that leaves 80% in here, and so it would leave 10% in this tail and 10%. So if I go to my table, let's look for 10%. Looks like I'm getting close, right? Looks like about this, right? Right there. So it's about 1.28. So going back here, that would be the same thing as we did over here, except for an 80%, it would be 1.28. So I think the next page, all I have is 3 examples. I'll come back and do maybe 1, maybe 2 of them, and then maybe I'll put the next one on the final. That might be a good idea, just to build a confidence interval. I will put at least 1 confidence interval on the final. It's a nice thing. You should be able to build one and understand now, hopefully, what it means. Let me go ahead and end this.